This is the DS1052E digital oscilloscope from Rigol. The power cord plugs into the side. Let's turn it on. An oscilloscope is basically a voltmeter. To demonstrate this, we'll use it to display the voltage output by this DC power supply. This is a two-channel oscilloscope. It can display input from two sources via two BNC sockets. A BNC socket has a central active connection and an outer ring that is usually connected to earth. We will use a coax cable to connect the power supply to the oscilloscope. This cable has a BNC connector, which we will connect to channel 1. And at the other end, banana connectors to connect to the power supply. Red to red, black to black. When we activate channel 1, we get a menu displaying options for channel 1. We'll be measuring a DC signal, so the coupling should be DC. We'll press the button next to the coupling setting to see what options we have. We can choose an option with the selection dial and confirm our choice by pressing the selection dial. We want to turn the menu off, so we are using the whole of the screen. But if we press the channel 1 button, that turns channel 1 off. So let's turn it on again. To just turn the menu off, we use the menu on/off button. You can see a small yellow 1 at the side of the screen. This tells us where our 0 is for channel 1. The yellow line shows us that the signal for channel 1 is currently 0 volts. At the bottom left of the screen, we can see that channel 1 is set to 1 volt per division. So each horizontal line on the grid represents 1 volt. The power supply is set to 2 volts, so when we turn on the power supply, we see the yellow line move up 2 divisions, representing 2 volts. As we change the input voltage, we can see the line move up. 3 volts, 4, 5, we're off the screen. I can adjust the volts per division to 2 to have the line reappear. And the line is now 2.5 divisions above the 0 line, 2.5 times 2 giving us 5. I can adjust the position of the 0 line. Let's put it at the bottom of the screen. If I now increase the voltage of the power supply to its maximum of 12 volts, the yellow line appears 6 divisions above the 0 mark, as we would expect. 6 times 2 giving us 12. If that was all a crow did, you might be wondering why we don't just use an analog voltmeter or a digital multimeter. The great advantage of an oscilloscope is that it can show us voltages that vary rapidly with time. To demonstrate this, we'll use a function generator to generate a varying voltage. We'll use a coax cable with BNC connectors on both ends to connect the output of the function generator to the input of channel 2. We'll set the multiplier of the function generator to 1K, which means that any value shown on the display is in thousands. We'll set our waveform to sinusoidal and the amplitude to minimum. Activating channel 2, we see a blue line at the 0 marker for channel 2. This time we'll leave the coupling as AC. Turning on the function generator, we just see a slight wave in the blue line. Not much of a signal, so what's going on? Our scale for channel 2 is 1 volt per division. Let's change this to 200 millivolts. Now we're seeing something, though it doesn't look like a sine wave. The function generator is producing a signal of about 1.0 kHz, about 1000 cycles per second, so the period of the signal should be 1/1000th of a second or 1 millisecond. We can see that one division across currently represents 20 microseconds, 40 times shorter. So we'll adjust this to 1 millisecond with the horizontal scale setting. Now we can see about one wavelength per division across. A nice feature of the digital oscilloscope is that if we muck up our settings, or we're not sure of the signal we are looking for, we can use the auto button to provide a first attempt at appropriate settings. This brief introduction should provide you with a head start when you use this oscilloscope.